All right, we're recording. Let's pretend that didn't happen. All right, guys, we're just starting the review. Nothing suspicious. So that was number 1. For number 2, this was like a question on the quizzes as well. Rational versus irrational. You kind of have to investigate each case. Be aware with radicals that you are allowed to multiply. You can multiply radicands. So like the things under the radical, you can multiply. And sometimes it works out nicely. Like A worked out nicely because 20 times 5 is 100. And that's just simply 10. You can't add radicals. I tried to trick you with 2b. What do you think I was trying to get you to do with 2b? What do you think I was trying to get people? Yeah, 2 plus 23 is 25. And then you go, oh, that's perfect. Oh, this works out nice. This isn't so bad. But we can't add radicals. Rad 144 looks ugly, but 144 is perfect. Be aware of that. The definition of a rational number is you can write it as a over b, but a and b have to be integers. You can't say like pi over radical 7 is a fraction, right? So it's got to be a fraction where the parts are integers. Yeah.
Wait, for number 1, could you go back to number 1 really quick?
Mm-hmm.
If you use like I did this, but when I first did it, I'd use like I think it was like negative b over 2a, and then
or the vertex.
Yeah, I got 8. But
yeah.
How is the 8 like? Isn't 8 the wouldn't 8 be the maximum?
8. So when we talk about maximum, that's the y value. 8 is actually the axis of symmetry. The vertex is 8, 256. So there's a lot of like Venn diagram overlap stuff there. So like the vertex is a point. That's 8, 256. The maximum is the y value of the vertex. That's just 256 by itself. So like they're all the same thing, just a slightly different context. Number 1, could you have done square roots? No, Studi. You can't do square roots if there's a plain variable. You can only do square roots in like the one we're about to do. Kyle, I hope that answered your question, but we can go back to it. For
Mr. Rice?
Yes.
For 1D, I'm not really sure how you got in the T-chart the open parentheses T minus 16, and then you did the T-chart, and also you got rid of the squared sign by the T near the 4. Could you explain?
GCF. So what do forts? You could do it other ways. Oh, okay. I think I know what you're saying, Studi. But what I did was I looked at it and I said, hey, they have a 4 in common and they have a T in common. So I factored that out. I pulled that out. So this is called GCF factoring. And then T minus 16 is what's remaining. So like when you pull out a 4 from each one, that's what's left over.
Okay, thank you.
For number 3A, again, using square roots. So isolate the squared term. When, like, if you're like, when can you do this? I'm not getting it. If you don't see an X, if you don't see a plain variable, whatever letter it may be, doesn't matter. Square root should be your option here, right? So I'm like, all right, there's no X. Let's just get this by itself and then hit it with the square root. When I get it by itself, be careful, double negative there. 36 over 49. What can you do with fractions when you take the square root? You can differentiate it. You could separate it. Rad 36 over rad 49 is a lot easier to do. That's just simply going to be 6 over 7. And don't forget, plus and minus. And this will answer, you know, I know I'm going over this even kind of quickly. It's just a lot of information. I want to try to do everything. But if you had a question like Kyle was asking about the vertex, it comes up in another one. So like so we'll try to hit everyone's question, but just be patient. For 4, it asks for a bunch of quadratic vocab stuff. So the vertex. What was I doing for the vertex? For the vertex, I'm doing negative b over 2a. That's going to give me the x value of the vertex. This is also a good example of why you can't always just say, I'm going to scan for it, I'm going to look for it. Why is this a good example of, hey, you can't always just look for the vertex? Why is this a good example of that?
Because the vertex could be a decimal.
Yeah, and look where it is here. Would you see this in your calculator table? No. So know how to do this. You get away with it most of the time and for most problems and most graphs, but just know how to do it the real way, quote unquote. And you could even use your calculator and change things. Like, oh, let me make it go by this. I've shown you guys how to do ask on your calculator, how to do change what your table goes by. So there are things you can always still do. The axis of symmetry is kind of answered when you do the vertex. Be careful if there is a question that asks you to write this. Some of you guys learned this the hard way in the quiz. Always say x equals. The roots would be setting it equal to 0. Roots means, hey, where does the function equal 0? What I did first was, if you're like, why did you write the same thing twice? I didn't. This is what I always tell you guys. You can't factor if a is negative. Factoring you can, but it's very confusing. So what I did to go from line 1 to line 2 there, the blue dots, is I divided out a -1. Now instead of like negative x squared, how do I factor that? Now it's just x squared. And I could do a simple sum product. So t-chart, I got 10 and 1. Those are my roots. The domain for any quadratic, so domain and range, let's look at my sketch here. The domain of any quadratic is going to be all real numbers, negative to positive infinity. The range, every quadratic is going to have a range that gets cut off somewhere. And once again, what is the deciding factor? The vertex. So range is looking like high to low. So does this graph have a low cutoff? No, it goes on forever. It goes all the way down forever to -50. But there is an upper cutoff, right? It doesn't go up forever. What's the highest this graph goes? That's going to be the y value of the vertex, in this case, 20.25. Okay. There were some classes that struggled with this one, I think, on the quizzes. It's just, I guess, weird phrase, but it wants you to come up with the original, like when someone's in the middle of solving a problem. So it's just a matter of doing box method. There are fractions involved. So when you do -5/2 times x twice, you end up getting -5, because that's -10/2 or -5. So there's fractions. You could use calculators for fractions. It ends up working out nicely, but that's how you do number 5. And let me just finish 6. Sorry for whoever has a question. For number 6, we write down what the roots actually are. We unsolve them, and then that gives us our factors. Okay, questions with the first page. Who had their hand up?
Oh yeah, for the range and domain, do you want us to write it how you wrote it for like number 4 or number 1?
If I don't say anything, you can write it however you want. There's nothing wrong.
Oh, okay. I see.
So you can even do like the inequality thing, Kyle. You could do symbols. You know, there's a bunch of ways with that. Maximus, go.
I'm a bit confused with 4D and 4E, specifically 4D, because I'm not really understanding why it's negative infinity to infinity, and same kind of problem with E.
So domain is like what x values work here, which x values are allowed in this equation. You're allowed to plug in any x value you want here. There's no cutoff. There's no restriction of like, oh, you can't really plug that in. You can't really do that. Because we can plug in any x value we want. So when we say negative infinity to positive infinity, that's basically saying anything. Any x value you're allowed to plug in. Now that changed, to give you an example of something that's not that, like square roots. Remember doing square root functions? You weren't allowed to plug in certain x values because you'd create negatives and you run into issues. Now for the range, that's what I explained as like, what's the lowest the graph goes, what's the highest. So this graph didn't have a cutoff in terms of how low it went. It did have a cutoff in terms of how high it went. The highest it went was 20.25. Range is your y values. Domain is your x values. Domain, you're looking left to right. Range, you're looking up and down. Okay. I know there was one on the quizzes that was a little bit more difficult than number 6. If you guys remember that one had a cube root that looked like this, right? What was the difference? Does anyone remember that weird one on the quizzes? What was the difference when it did that? Sorry.
It was skimming the x-axis.
Right. We call that a double root. And sorry, I'm just seeing the chat. Yes, very good. So when it skims, we use it as a double root. Multiple choice. The whole test is on Friday. It's just multiple choice has to be done in class. Does it matter the way we write the domain? No, doesn't matter, Kara, either way. For number 7, I exclusively told you to use CTS. Exclusively, and to be honest, even if I didn't tell you, number 7, you probably should do CTS. Because look how nicely it is. B is even, the constant's already over. The magic number is 9. Remember, the number that you add on both sides is always going to be positive. I haven't decided the time yet. the number you add to both sides is always going to be positive because the formula is b over 2 squared. So if you're someone that has trouble with finding that number, just ignore signs. It doesn't matter that this one is -6. Just ignore signs. Cut it in half and square it. What's the trick again? That could have answered you a multiple choice today. What's the trick to go from here to here? It's not even a trick. What's the process to go from here to here all the time? Cut it in half. Same sign, right? If it's minus, it's got to be minus. Because what you're really doing is breaking that up into 2 equal groups. So like we have -6 being broken up into 2 equal rectangles, if you remember like the visual. Okay, and then we do square roots. We try to simplify radicals. Just to explain radicals, I think there's a few people floating out there that don't have any idea how to do this still. Like you're just randomly putting radicals places. We break it up into factors where one is perfect, and then the perfect one can simplify. For some reason, people just start throwing radicals around, and they'll do like 6 radical 4, and my brain explodes. So just make sure you understand how to simplify radicals. And then when we bring the number over, we sandwich the plus minus in the middle. And that's it. Okay, discriminant. Discriminant was, I don't remember if we did a video on it. I don't believe so. Discriminant was the lesson where we just do the radical part of the quad formula. We didn't know the quad formula at the time we did this lesson, but now we know it's like the radical part, and it will tell us about the answers. The discriminant doesn't tell you what the answers are, so you might be saying like, oh, that's kind of pointless. But there are questions where we don't have to do the whole process, and it will tell us about them. If you have a good memory, like number 1 that we went over on the quizzes today was like that. So in this case, a of x, I know a of x is going to have one real rational answer. I don't know what that is, but I know it has one real rational answer because the discriminant is 0. If I were to actually sit and do the quad formula, I would get a 0 under the radical, which means the plus minus doesn't have any impact. There's no radical in my answer, so it's rational. There's only going to be 1, right? For b of x, I get a negative. Now, what would that mean now that we know the quad formula? That means we would get a negative under the radical. So this is our imaginary case. This one has no real answers. There's no real answers. It doesn't actually hit the x-axis. It has imaginary stuff, but no real roots. For the other case that's not mentioned here is if you get a positive number, you know that there's 2 roots. And what's the breakdown between knowing if it's a rational or an irrational when you have 2? If it's 0, you automatically know it's rational, right? If you know, like, because the discriminant's 0, you know 1 real rational answer. But how do you know if when there's 2 answers, if they're rational or not? Kyle, that's what rational means, but with the discriminant I'm talking about. If it's a perfect square, if you do your discriminant and you get a perfect square, think about it, that means in the quad formula you'd have a perfect square under the radical. If you get, let's say, 40 as your discriminant, you know that there's 2 irrational answers because you'd be stuck with rad 40. Okay? Bob was solving, yeah, this was a weird one. I had to kind of like be creative with how I created this one, but like, because I wanted you to find what the factors were. You had a multiple choice like this today. So basically, like, what was the step right before he would have solved it? So it's like forcing your hand and factoring it. So it was 2x plus 1 times x minus 5. So you basically have to start the problem from the beginning. You're factoring it. How do I know to factor it? Because it's literally double bubbled. It's just that his got erased, and you didn't have to solve it. So you stop right there. With factoring, remember, what am I doing here? Trash. Where does negative 10 come from? 2 times negative 5. This is our eyeglass factoring, we call this. Review factoring if you need to. Graphing calculator stuff. Graphing calculator, I'm not going to switch over. That's like a 2-minute process. I could do that a little bit later on. But with graphing calculator, second trace. Type them in, second trace. You're going to get the flashing cursor. Move it closer to whichever one you want. Enter 3 times. Pop, 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 3 times. You'll get an answer. Do it again. Move the cursor to that one a little, closer to it. It's going to reveal whichever one it's closer to. Doesn't have to be exact, but just move it closer. I'll go over the double root thing in a second, and then we'll reveal that one. Just round it. It's going to be a crazy answer like this. So this said nearest 100th. With the double root, we were talking about this guy. So like, for example, we'll do it with the quadratic. Let's say if I said like, hey guys, what's the equation of this quadratic? And for argument's sake, let's say that this is 2, right? you would start off by doing this. You'd be like, all right, that's all I know about this question. I know it has a root at 2, x equals 2, right? Now, if you unsolve this, you don't have anything else to kind of work with. So what we did was we wrote it twice. We said, all right, x minus 2 times x minus 2. That gives me something to start like, all right, I can multiply these together. So anytime we have this like tangent means like touching once, skimming, I gave like a more understandable word for you guys for. Anytime we have that, we repeat that twice to create kind of what we want. I'm losing it. I just had Mad Team for an hour and then this. Okay, so we had a question like this in multiple choice today.
Mr. Rice, you're frozen.
Am I still here? Can you hear me?
Yes, I can hear you now.
Cool. Is my iPad still sharing? Okay. My computer still thinks it's on school Wi-Fi. The long way of doing this one, and I'm still recording, okay. The long way of doing this one is like unsolving and multiplying together and then doing AOS. What's the shortcut? The axis of symmetry is literally in the name itself, right? It's going to be symmetrical. So it's going to be the same, whatever this distance is, it's going to be the same over here. I know that's not drawn to scale. So what I'm doing here, it looks like I'm taking the average. I'm trying to figure out what number is in between -10 and 3. And the answer is -3.5. Another example, let's take a really easy one. Let's say the roots were 2 and 4, right? What would the AOS be if the roots were 2 and 4? Where would the axis of symmetry be?
3.
3. Yeah. So it's always going to be literally symmetrical. I know these numbers are a little bit harder to do in your head. That's why I'm adding them together and dividing by 2. That will tell me the middle. That will tell me the middle. Okay. This one's solving. I showed both variations, whatever you're comfortable with. If you're more of a CTS person, if you're more of a quad formula person, I split screen this. I personally, what would I do with this? I would CTS this, given the problem. Some people like quad formula, but I would CTS this. CTS saves this step. CTS saves all of this. You don't have to do this hard stuff, because look at CTS. There is no denominator, but it's up to you, whatever you're more comfortable with. Okay. A quadratic has a single root. So I was just explaining that before I lost connection for a second. Write it twice. Write it twice. Double root problems, write it twice. Unsolve, box method, multiply it out. I'm just doing FOIL there. Vertex form just has the vertex in it. So if the vertex is at 5, 0, that's the formula. There's really a +0 on the end, but that's not significant. You could cheat a little bit with that. So if you know where the vertex is, you could just write it in the vertex formula. Any questions with the second page? Questions with the second page? Go ahead, Lucas.
For the graph in question, my graph goes off of the actual grid that's shown, so I can't see the second intersect.
Say it one more time, buddy.
I can't see the second intersect because the graph goes outside of the screen.
The second intercept. For which question? Which
It
number?
was question
Are you
10.
in the fourth dimension or something?
Wait a second, I'll connect the mic.
You sound like you're like in a spirit realm.
It's better?
Yeah, it's fine. Go ahead. Do you remember the number?
10.
10? 10, you said?
Yeah.
Can you type it in the chat? Now I can't hear you at all. I don't know if it's just me.
He said yeah.
10? Okay. For 10, it was off your screen. Let me see what he's talking about. Hit Zoom, try Zoom 6, Lucas. Zoom 6 is like your go-to if it's off the screen. Because it should, oh, no, you're right. Good question. So one of them is, because I see this one is 13, you're right. So you can also zoom out. If you have your calculator and you want to follow along with me, I'm not going to share my screen, my calculator screen, but he's right. That's a good question, Lucas. I'll hold it up to the screen. This is not going to happen on Friday, but it's a good learning experience regardless. This won't happen on Friday. So do you see what he's talking about? I don't know if you guys encountered this problem and just figured it out. Do you see, like, we know they're going to hit over here, but we don't know where that is, right? So instead of Zoom 6, what you can do, there's a button that's hit Zoom. I believe it's choice 3, zoom out, and then hit enter. So when you zoom out, it's kind of like pinching your iPhone or your iPad. Now it gives you this picture. And now this, you could do like second trace, and you should be fine. So hit Zoom 3, Lucas. Yeah, the issue was it was like slightly off the screen. All right, for piecewise, we haven't done this in a little while. For piecewise with quadratic, we had a lesson on this, like revisiting piecewise now that we know quadratics. Remember with piecewise, we do tables. We don't need it to be symmetrical. This isn't symmetrical. We usually do the vertex in the middle. That's fine. It's based on the restriction. There's a typo with this one. Remember, change it if you didn't change it. And we do open and close circles. Like if it has the equal to slash, it's closed. If it doesn't, we still include it in the table, right? Like here, I'm still including -6. I'm just going to -2, 6. I'm just going to use an open circle to represent the fact that it doesn't touch. You don't like slide over. Sometimes we get you're overthinking it too much. Like, all right, it doesn't touch, so let me go to -1 instead, or whatever, -3 instead. So you go to that number, you just use an open circle. Yeah, they take a decent amount of time. Maximum. What does maximum refer to? With a quadratic, there's maximum and minimums. Does anyone want to tell us what maximum and minimums are?
Maximum is the highest phi value in the quadratic, and
Right.
minimum is the lowest.
Yeah, the vertex, first of all, the vertex is always going to be a max or a min. It's a max if it's that sad face. It's a min if it's that smiley face. Okay? So in this case, when they say largest maximum, they're saying the y value of the vertex. There's even a fill in the blank above that. Those are my blinds. So visually, the easiest one here is the graph, right? Or even like the table. Now be careful that the maximum isn't 9 just because you see a 9. You know that the maximum is going to be slightly larger than that. I said 9.5. It could be like 9.25 or something, because remember, it's going to be in between the symmetry. So the vertex is at like 1.5, let's say, right? So slightly over 9, a little peak above 9. The maximum here visually is 4.5. Okay. It's a little annoying, but 1 and 3, you have to like do your formulas probably, or use your calculators. For number 3, you're not going to see the maximum on your calculator screen. I guess you could look and see that it's going to beat 9.5, but what I'm actually doing is my formula. My formula to find the maximum is going to be -b over 2a. That's going to give me the x value, and notice what I had to do here was plug in that x value to find what the actual maximum is. So you basically have to find the vertex. To find the vertex, -b over 2a, and then plug that value in. So who wins here? Choice 3, 11.2 is the largest max. All right, I know this is a lot. It's taking a lot just to go over the review sheet. For this one, we have the perimeter and area. We did a few like this, so you could probably guess what you're going to see on Friday. We set up our perimeter and area formulas. We plug in what we know, and then this turned into like a system of sorts, if you have a good memory, and we're using substitution. So in my case, I solved for L. You could have solved for W. You could have solved the other equation for L of W. There's a few variations with this. And then once you do substitution, the quadratic develops. The good thing about word problems is, for the most part, they should be factorable because we're talking about measurements here. You get 2 answers, but do you really get 2 answers? No, because you get 17 and 6 or 6 and 17. So those are the same rectangle. They're just switching what's called what. So the answer is it's a 17 by 6 garden or whatever this is.
It's alright.
What?
But if on the thing, but isn't it technically too, like, they're 6 by 17? Like, can you just write both, or
Is 6 by 17 and 17 by 6 different rectangles?
they look different?
It's the same numbers.
Oh wait, so we only have to write it one time.
Yeah, just write it once.
Oh, okay.
What you call length and width for a rectangle is what we call like arbitrary. It doesn't matter. Like you could look at it and be like, oh, I'm calling this the width, and someone else could be like, oh, I'm calling this the width. Like, does it really matter? No, because what you call what, like, it's still going to be the same rectangle. That's not the system. This was from the problem. Like that, they told us the area was this and the perimeter was this. These are the area and perimeter formulas you would need to know to kind of create the system. This one we did like as a do now in all 3 classes today. What's the little trick here? Make sure to actually multiply it by 2. Do you really care about simplifying the radical? No, this one I don't think simplified anyway. And we're rounding to the nearest tenth, so type it in your calculator. This is like the lazier way of typing into your calculator using parentheses. The other way would be using the fraction feature to actually type it in as a fraction. If you type it in like this, your calculator is just going to do 105 divided by 4. Okay? So be careful with that. But I think we were pretty okay with that after doing it as a do now. I didn't get a ton of questions on that. And then the very last one, number 18 said, this was kind of like the site A and site B one, if you guys remember that from a few days ago. So if you remember, and we even have like a picture of it here, a similar scale, why are we graphing the line with the table? Can anyone tell us why are we graphing the line with the table? That was kind of the trick with this one. Something was like weird about it. Yeah, because of the scale. The scale is different for X and Y, which makes slope annoying because when you move, it's not the same. Moving, in this case, the slope is 1. Even moving 1 is weird. Usually it's up 1 over 1, which is the easiest thing you could do. In this case, if you wanted to move up 1 over 1, it would be like up a half of a box and over 5 boxes. I don't know about you guys, but that's confusing. Or you could do like up 2 boxes over 10 boxes. Super confusing. Just use a table of values. You can cheat and just use 2 points, the very beginning and the very end. Use a straight edge or a ruler to connect your line. Always remember to label if you're doing a system. And there's a follow-up that said like find A of 6, find B of 6, and stuff like that. Okay, questions with the review? What we'll do next is, I don't want it just to be me talking the whole time. I don't mind if we take a few more questions, but we'll try some practice after this. I posted a file called written practice if you want to pull that up on Classroom. But any other questions with the review sheet that you feel you still don't get quickly? Can you elaborate on it? Lucas, go ahead.
For number 2, this is just to actually not number 2, number 4, just to refresh. When you converted the x over 2 minus 11x plus 10 into parentheses, to do that, did you just find out what adds up to negative 11 and multiplies to 10?
Correct. Why I did that, remember see the 2 blue lines?
Yeah.
So what I did to go from the top blue line to the second blue line was I multiplied everybody by -1. You can only really do factoring if it's like a positive x squared. When it's negative, it's like super weird. So what I did was I was like, I want to get rid of this negative. So I hit everyone with a times -1. That's why everybody's sign changes. The 0 doesn't have any impact, but everybody's else sign changes. Now it's an easy sum product. I suppose so. Yeah, you could technically do quad formula for that one if you wanted to, going with what Lucas was just asking. Studi, what's up?
So I think for number 9, for the Bob question, how do you know that like you have to set them equal to each other? Because in the question it doesn't really like directly tell you that you have to set them equal to each other. So I misunderstood and I like solved each one.
Right. It's not very, but it does say he's solving the system, which implies that he's setting them equal to. Yeah, wasn't very clear. It did say he was solving this. How would you solve a system? You set them equal to each other.
Oh, okay. Oh, and also one more question for number 1, and I think the part was D. Can you solve it with another method except factoring?
Don't say quad formula, but sure. No, you could. I think factoring, GCF factoring is probably the fastest.
Okay, thank you.
All right, anyone else with the review sheet?
Yeah, one last question about question number 8. How did you convert the 64 minus 64 equals 0 into what you have on the right side? I was just confused about that.
Number 8. Say it one more time, the question, I'm sorry.
That 64 minus 64.
Mm-hmm.
How did you convert
How do I
that?
know? How do I know that means one real answer?
No, I'm confused as to where you got the right side from.
What do you mean the right?
Never mind. I was looking at the wrong thing.
Okay, no worries. All right. So what I want to do now, let's take a look at the actual practice. This way you could like do something if you were like coming here and you're like, hey, I want to actually do some problems. Maybe not. Oh, here we go. Okay, these are posted with answers in case we just, or you have to leave or something. We probably won't do all of them. Let's try this one to start. So a quadratic function, f of x, has roots at x equals -2 and x equals 12. These are available on Classroom too if you'd rather look there. Write a possible function for f of x. We say possible because there's things you can do to create, an infinite number of them in Vertex and in standard form. And then there's a little refresher there about the difference between the two. So take a few minutes to try this one. I'll give you a hint. Start with doing it in standard form. Don't try to do it in Vertex form first. Start by doing it in standard form. Does anyone want to tell us what to do first? What would you do first?
You would, well, what I did first is that I made the -2 a +2 and the +12 a -12.
Good. You make them into what we call we'll call these factors, right? Like bubbles, we sometimes say. So make them into like their bubble forms, right? And now what do we do with these two bubbles?
Box method.
Box them out. Box them out. You'll get x squared. 2 times x is 2x. -12 times x is -10x when you combine the two. And 2 times -12 is -24. For you guys, draw the box method. I'm just doing it quickly now. Okay. Now it says possible. We had a multiple choice where like you did this today and then you didn't see it there because everything was just like multiplied by a constant. Like another variation would be 2x squared minus 20x minus 48. So if there's a multiple choice, look for multiples of that particular expression. Okay. Now what can we do to write it in Vertex form? We could do completing the square to actually do like the Vertex process, or we could cheat a little bit. We could simply just find the vertex. So let's see if we could, this one should have a nice vertex. Let's type it into our calculator. Just to save time, right? Let's say you want to be efficient. You're like, oh, I don't feel like doing, there's a real way of doing this. And, some hacky type ways. Does anyone see the vertex by scanning? So John, I was saying, like, let's see if we see it. If we don't see it, then we could dive into that. But yeah, you're right. Yeah, you clearly see the vertex is at 5, -49. If you don't see it, or if you want to do it, just do it the legit way, like John is saying, you would do this, -b/2a. Or you could do completing the square. Completing the square is actually how you write it in vertex form. We did a lesson on that. But now we can just kind of plug in the vertex into our vertex form. We know there's no coefficient of a, because we know the standard form version of it. We know there's nothing in front of x squared. So this should be x minus 5 squared minus 49 in vertex form. Okay, remember you make the number in the bubble the opposite. So even though it's plus 5, we write minus 5 in our bubble. Cool with that one. Questions with that one?
Mr. Rice,
Yes.
do you have to put f of x, or could you like you did
Ooh,
y equals?
Yeah. You should always use, if they tell you to use a particular name, just make sure you use that name. It's like a weird thing, but yeah. Good catch. Okay, let's do another one here. Let's try this one. Try this one. I won't say anything. I'll give you guys a few minutes. Try that one. Where's the 40? We just looked for it, Lucas, on our calculator. So we typed this in and we just saw that what you're really looking for is like that symmetry. So we at 5, -49, I'll hold it up if you could see it. I don't know if you could see that. See how at -49 everything like mirrors around it? The other real way would be to do like the formula. Just give me 1 sec, guys. Work on this. I'll be right back. Do I watch the recording? No, I don't. Why would I rewatch all this? The chat doesn't show in the recording, just so you know. Your voice does. So people that are talking, you're famous. Your voice does. John, they'll hear that voice crack. Kyle, you left your hand up. All right. How are we doing? Song request. Ethan? Is Ethan here? Where's my boy Ethan? Ethan's not here. Where's little E? Only 722 knows that joke. The other classes don't know that joke. Okay. So read this carefully. This is a system, but they want to know where it equals 3 times h of x. So we're going to do this. Now we're going to multiply it by 3. Now we're going to subtract 6x from both sides. Now we're going to subtract 21 from both sides. Now I'm going to gauge how I should solve it. It's probably not going to factor, especially because they said nearest 10th. Don't want to do CTS, so what should we do?
Quad formula.
Quad formula. So write down ABC, write it down. There's a reason why I told, when we did the lesson, I said that as one of the steps. There's a reason behind it. When you start to plug things in without writing it down, that's where you make mistakes. Positive 3 because it's negative b, don't mess that up. And what's the discriminant here? 9 plus 264, 273? Oh, 273? Okay. Don't do that in your head. Now, we don't even care about simplifying that. I'm not even sure if you could, to be honest, because we're doing it to the nearest decimal, right? So 3 plus radical 273 in parentheses or in your fraction, whatever you're comfortable with, divided by 4, and this is said nearest 10th. One answer would be 4.9. The other answer would be something. The other answer would be negative 3.4. I messed up something? Wait, did I mess up? Oh. Yeah, the 9. Oh, you did negative. No. Be careful with b squared. I thought you made that mistake. And what?
Well, we discussed it in class.
Because I'm wearing headphones. Like when I wear headphones, my voice is going to sound different.
You just sounded like much happier. I don't know why.
You either went through puberty or became depressed.
Or he hates us.
Honestly, any could be true.
Maybe I liked my G&T classes last year. Okay. Wait, did I say that out loud? 4.9 and negative 3.4. No, I'm joking. I'm joking. I did have them for 2 years, though. I had 6th grade G&T, and then I had them the year after. Which we thought we were going to do again this year. Like Miss Mavro was supposed to follow you guys, I think. And I was supposed to get the 6th grade. Like, we usually do cycles of 2 years. Sweeney does 8th grade. Sweeney. Okay. Questions with that one? Questions?
Mr. Rice, who would the 6th grade have if Miss Mavro went to 7th grade and you went to 8th grade?
I wouldn't have gone to. What? What? Give me a sec. She's teaching her class too right now. What was I saying? I forgot what you were asking, Maximus.
Wait, so when you rotate, is it like, so 1 year you're teaching 6th grade and then Miss Mavro's teaching 7th grade, then you flip?
Yeah, you flip. So you follow your class for 2 years. So like, you start with the 6th grade, and you follow them into 7th, and then you rotate back. We did that. Like Mr. Peralta and I did that for a few years. Right.
Okay, so my brother would have had you if we didn't do the flip. If we did do the flip.
Okay. And let's do one last one to close it out. All this stuff is available online. Let's do this one. This is a good written one. I'll give you guys a few minutes to start this. She's teaching right now. I don't know actually. 8th? I think 8th. Hajima. Am I supposed to know that? A new version of This Is Us is on NBC. Okay, we know our area and perimeter. Area of a rectangle is length times width. Perimeter of a rectangle is 2L plus 2W. So write those formulas down. We plug in, and that gives us our system creation. They tell us to use X and Y, actually. So instead of LW, let's switch to XY. Do we not live with each other? What? No, I don't. I've watched a few episodes here and there. Okay, so now what you would do, I usually work with the perimeter one because that one's going to be easier to work with. If you solve the area one, you get like a fraction by itself, so that's a little bit more annoying. So let's work with the perimeter. I divide everybody by 2 because everybody's even. And now let's solve for x. So I'm going to subtract y from both sides, and you get 32 minus y. Now we're going to take that and plug it into the other one, replacing x with what we know x is equal to, 32 minus y. 32 minus y times y is going to give us 240 equals 32y minus y squared. We're going to get the y squared positive, so bring everybody to the left here. And now we're looking at a sum product. What adds to negative 32 and multiplies to 240? It should be negative 12 and negative 20. So y minus 12, y minus 20 equals 0. Do your t-chart, you're going to get 2 answers of 12 and 20, which means the other variable is 20 and 12. So same thing. The dimensions of this rectangle should be 20 feet by 12 feet.
Mr. Rice, is the I don't know because it's always tripping me out when you like do your I don't know if I think it's a 4. It says 2y or 240. I don't know. It trips me out. So
Yeah, it's a 4. I need handwriting, but when I go fast, it's not so good. Sorry.
Mr. Rice?
Yep.
So when you use the 64 equals blah, blah, blah equation, I know you divided by 2, but can you just explain again why you moved the y to where the 32 is?
Because your goal is to solve for a variable there. So like I chose to solve for x. Doesn't really matter, to be honest with you. So what I said was like, all right, let me get y out of here. So I'm going to subtract y from both sides. And now that's where you get x equals 32 minus y. I just like flip their sides as well. That doesn't matter. Switching left and right.
Okay, thank you.
Okay. All right, guys, any other questions? There's a ton of updated resources. I'll post this video as well, but we have the review sheet answers, quizzes answers, and this kind of practice file. These are good practice for written. So these are specifically, hey, you'll see this as written. You skipped your
Mr. Rice, how many questions are there on the multiple choice and on the written?
15 and 6.
15 and 6?
Mhm.
Okay, thank you.
One last thing.
Sure.
You know how when you got all the y values and stuff like that, will there ever be a time where the y is a negative?
No. If there is for a word problem, Lucas, what do you do? For like, let's say this, where it's a measurement.
Multiplied by a negative 1?
No, like let's say you get your answer and it's a y equals negative 12 feet, you would reject it in this problem.
Okay, thanks.
No problem. What's up? Who else had a question? Any other questions? All hail. What is this? Tell people to hail anime fish. We need to respect the departed king. I'm sure that won't get. What is this? I'm gonna pretend I didn't fall for that. All right, guys, have a good day. We'll cut off the recording.
Wait, will everything on the review sheet also be on the test?
Yes, sir.
Okay, thanks.
All right, guys, have a good day.
Mr. Rice, tomorrow if we email you, will you be able to respond to if any of our questions if we have one?
Possibly, yeah.
Okay, thank you.
Don't email at like 4:30 a.m. But yeah, reasonable time I can respond.
Okay, thank you. Have a great day.
You too, guys. Bye. Not quick enough. All right, bye, guys. Stop recording.